এখন কি can you see the screen? Okay. So here we are in this feedback topic. So what we are doing, we are going to take some part of the voltage output into the input terminal. So this voltage output that I am feeding back to the input terminal, that is what we call as feedback. এবং যখন আমি এটা করব তখন I can feed the whole voltage output back to the input, or any part of the voltage output, any fraction of the voltage output back into the voltage input. This is the adding unit. As you see, adding unit. The voltage input is supplied from that terminal. The voltage input is right here at this terminal. This is the adding unit. If some feedback is here, the input voltage is adding up with that input voltage, adding up with this feedback. So ultimately, this complete input voltage is passing to the amplifier. সেখানে gain আছে, and ultimately this is going to give you some voltage output. The process of taking some or all of the output of the amplifier and adding it to the input is known as feedback. So this is the formal definition of feedback. Process of taking some or all. If you want, you can take the entire voltage output back into the input terminal, or you can feed part of the voltage output into the input terminal. So process of taking some or all of the voltage output of the amplifier and adding it to the input is known as feedback. So the feedback fraction here is denoted by beta conventionally of the output voltage. So beta can be maximum to be 1. So 1 means that it is as much as the voltage output, or it could be any fraction of that. So a fraction of beta, which is a part of the voltage output, is fed back and added to the input voltage. Amplifier itself amplifies by an amount of A naught, whatever voltage is present at its input. So as we already have seen, the voltage, the operational amplifier has the open loop voltage gain to be denoted as A naught, এবং this A naught is the amplification, which is the gain of the amplifier itself. When you are using this operational amplifier, you are going to amplify the signal. So this amplifier has this much signal. The ideal amplifier has infinite gain, and the real open loop amplifier has 10 to the power 5 as the value of the gain. So this gain is denoted by A naught. If we are going to see that how the equation, this one, is derived for the feedback amplifier. So what we have come to see earlier, that output voltage is A naught times the difference between the input voltage, isn't it? Difference in input voltage. আমরা অপারেশনাল ওপেন লুপ ভোল্টেজ গেইনের জন্য এটাই দেখেছি না? This is for open loop voltage gain বা open loop amplifier. This is what we have seen earlier, that output voltage is A naught times V plus minus V minus. That is the difference between the input voltage. This was for open loop amplifier. And right here it is not open loop, rather the voltage is fed back to the input. So for feedback amplifier, what we can say, the output voltage is A naught times the total input to amplifier, total input to amplifier. Now, A naught is the gain, total input is how much? The input itself plus any fraction of the output voltage. So the fraction of the output voltage is denoted by beta, which is fed back to the input terminal in the adding unit. So this is beta V out. This is the total input in this input end. Now if I just simplify, this is taking all the V out in the same side. It says this is V out and this is A naught beta V out, isn't it? This equals to V input times A naught. And taking V out common, it is 1 minus A naught beta, and this is V input times A naught. So if you are going to take the ratio of V out and V in, this comes out to be A naught divided by 1 minus A naught beta. And this ratio of output voltage to input voltage is known as gain. This gain of the feedback amplifier is this A naught divided by 1 minus A naught beta. This is what you can see right here in this expression. Let me know if you understood it, or ask me if you have any question. Open loop voltage gain open loop amplifier এর জন্য, this was the equation we used. For the feedback amplifier, the equation is actually theoretically is this, and this is the derived form of this statement, that output voltage by input voltage is A naught gain divided by 1 minus gain times beta. Beta is the fraction of the output that is fed. Fraction of output which is fed back to input. Any question? So for this second slide, the negative feedback, that is right here, illustrated by this diagram, that the feedback. So when we look at the operational amplifier, the two input end, one is V minus inverting terminal, inverting end, and there is V plus non-inverting end. That is a inverting V minus, and V plus is non-inverting. So the output is fed back to the inverting end, and it is here, if the feedback, if the fraction beta is negative, so look at this equation, V out by V in, which is the gain. This gain is V out by V in which is A naught divided by 1 minus A naught beta. Now, if beta is negative, so look at this equation. If A naught is, if beta is negative, then the denominator is becoming 1 plus A naught into beta. So the denominator is going to be greater than 1, right? So if beta is negative, denominator is greater than 1. If it is greater than 1, then the gain is smaller than open loop gain. This is the feedback gain, and this gain is smaller than open loop gain. Can you relate it with this equation? If beta is negative, then this denominator is going to be greater than 1. It is going to be increasing. If it goes up, this will go down. Then this gain is going to be less than this open loop voltage gain. So gain is going to be smaller than A naught. এবং এটা আমরা কিভাবে পাচ্ছি? We are achieving this thing by feeding back part of the output to the inverting input. By feeding back part of the output to the inverting input. This is how we achieve the gain to be smaller than open loop voltage gain. Why do we need the gain to be smaller than open loop voltage gain? Because the open loop voltage gain, which is of the order of 10 to the power 5, such a high value, which is why the amplifier gets saturated, isn't it? So amplifier gets saturated of this high open loop voltage gain. So this gain should be reduced to that certain value so that it does not get saturated, and simultaneously it will give you some more benefits. So these benefits are very essential to know, because these three benefits to be written in your answer script. This question is quite frequent. It increases the bandwidth. What increases the bandwidth? The feedback. So the question is, what is the advantage of using the feedback amplifier? Why do you use feedback? So this is the benefit of feedback. It increases the bandwidth. To be a little more elaborate, you can say the increase of range of frequency over which gain is constant. Okay? It operates in such a way so that in an increased frequencies, the gain remains constant. Distortion is reduced, and operating stability is maximized, optimized. So these are the three benefits, advantages of using a feedback amplifier. And for this gain to be less than A naught, to achieve the gain to be less than open loop gain, feedback is done with inverting input. Okay, তো আমরা এখন এই ফিডব্যাকের একটু ডিটেইলসে যাই। Up to this much, is it clear? Any question up to this much? Okay, let me go to the next slide. So this is the inverting amplifier. So এরকম feedback amplifier can be of two types. One is inverting amplifier, other is non-inverting amplifier. So we start with this inverting amplifier. So if you just look at this diagram, a little more clearly, you see the output here is right here. It is connected with the input terminal via our resistance, and that is how we define it. We denote it to be RF, resistance in feedback, resistance, feedback resistance. And this is what we say RI in or RI. Either we say RI in subscript or RI, that is input resistance. The inverting amplifier is that amplifier which is obviously a feedback amplifier, and the input voltage is fed into the inverting end, not at the non-inverting end. Inverting amplifier is that amplifier where the input voltage is supplied into the inverting end. And you see the non-inverting end is by default grounded. It is at zero, earthed. The inverting end here where the input voltage is supplied. So here the input voltage is supplied. It is not that the inverting end is also grounded. It is not grounded. Grounded respected the inverting voltage or voltage that is to be measured. But the voltage has been supplied, fed into the inverting end, and the non-inverting end is grounded. That is earthed. So right here it is obviously zero. Without on it. It is inverting. Again, by its name, it suggested that it inverts the signal. So if the signal is sine, positive sign, it inverts it. It is made as negative sign. If it is positive cosine, it is made as negative cosine. So it just inverts the signal. Here we say আমরা derivation যাওয়ার আগে let's get acquainted with what inverting amplifier is. So inverting amplifier inverts the polarity of the output. Signal কে সে invert করে ফেলে, just 180 degree opposite করে ফেলে. So this is that what we call, it is pi out of phase with the input voltage. The inverting amplifier inverts the polarity of the output, not of the output, at the output of the input, you can say. The polarity at the output is just opposite, inverted, and the output voltage is always at pi out of phase with the input voltage. P out is always at pi out of phase. So if the input voltage is positive sign, the output voltage will become negative sign. If the input is positive cosine, the output will become negative cosine. So you can look at these two diagrams, two graphs. Now here look at one more thing which is very frequent to ask. This position of P is right here, is known as virtual earth. What do you understand by virtual earth, and why P is to be at virtual earth, or P is made to be virtually earth? So আমরা জানি যে for the amplifier not to get saturated, V plus should be very much same as V minus. এটা আমাদের very common basic principle of Opamp. Because of having very high gain, V plus must be same as, or base must equal as V minus. It must not be as much as equal to uh, V minus, but it should be very close to V minus so that the op-amp does not saturate. So at this V plus, the voltage is 0 because it is earthed. This is the first point. For the op-amp not to get saturated, V minus should be almost same as V plus. Almost same as V plus. So this sign is very important. You are not supposed to write V plus should be same as V minus. Then the difference will become 0. Then gain also will be 0. It is very much same as V minus. So therefore, at point P, the voltage at point P is going to be almost same as V plus, which is almost 0. That's why it is known as virtual earth. So it is actually not earthed, but it is called to be virtual earth, just to be same as the voltage at the non-inverting end. Same na bole bole similar, very much same to be the voltage at the non-inverting end, so that the op-amp does not get saturated. Is this clear, sir? So this is here the question, the answer of the question, why P is known as virtual earth. So this question is very frequent. You must write the answer in this term, that at non-inverting end voltage is 0. For the op-amp not to get saturated, this should be equivalent to V minus, V plus should be equivalent to V minus. So since P is at the inverting end, so the voltage at P is what we call as voltage at the inverting end, which we call as voltage at the non-inverting end, and which is approximately 0. So that's why the Vp is to be considered as 0, and we call it to be a virtual earth connection. Have you understood that why P is virtual earth? Did you get the answer of this question? P is virtual earth. Why? So what we are going to write? We are going to write that at non-inverting end, but input V plus is 0, as it is earthed. For amplifier, this is essential to write. Why V plus should be almost same as V minus. For amplifier not to saturate, V plus should be almost same as V minus. P is at inverting end or inverting input. So Vp should be same as V minus, should be same as V plus, which is to be 0. Hence, P is called as virtual earth. So this is the answer, why P to be at virtual earth. Now we are going to get the equation of the inverting amplifier. So as I mentioned earlier, that here in the inverting amplifier, what we are going to do, we are going to feeding some of the voltage back to the input voltage, and here there is a resistance at the input terminal and at the resistance I mean at the input end and at the feedback end, the feedback part as well. One we call as resistance input and the one is resistance through feedback. So this is the input terminal, input voltage, input voltage which is supplied to the inverting end of the amplifier. So this is the inverting end. This is the non-inverting end which is grounded. So for inverting amplifier always the V plus should be grounded. V plus should be always grounded for the inverting amplifier. Input should be always given to the inverting end for the inverting amplifier. This is the inverting amplifier we are talking about. Input V in is always fed into V minus. This is V minus. P is the point right here. From this point, this connection is made with the resistance, feedback resistance, and this is here the output voltage V out. As we already discussed, that the input, output, everything should be measured with respect to the ground. So ground is respected output voltage. Yeah, this is. And right here we have one input resistance as well in the input terminal. This is the input resistance. This is the feedback resistance. The thing is here, when I supply this input voltage into the inverting input, so this I is flowing through this input resistance and then it reaches to point P and the full I goes through this feedback resistance. The full I, entire I goes to this feedback resistance. Why? Because as we already have seen that the amplifier has infinite input impedance. Can you remember that? The amplifier itself has infinite input impedance. So, because of having infinite input impedance, it is not going to draw any current inside its circuitry. So এই অ্যাম্পলিফায়ারের সার্কিটরির মধ্যে কোনো কারেন্ট যাবে না. So that current, full current is flowing through the input resistance. So that is what we can say, which is going to give us the clue for deriving the expression for the inverting amplifier. That I through input resistance is same as I through feedback resistance. যে I এই টার্মিনাল দিয়ে যাচ্ছে সেম I এখান দিয়েও যাচ্ছে. Okay, and what we know that I equals to voltage by resistance, isn't it? তাহলে ইনপুট রেজিস্ট্যান্সের রেসপেক্টে যে ভোল্টেজটা, সেই ভোল্টেজ কত? এই ইনপুট ভোল্টেজ এখানে দিচ্ছি, সেই ইনপুট ভোল্টেজ কারণে কারেন্ট যাচ্ছে, this current is flowing through this input resistance, and right here at point P the voltage is 0 because P is at virtual earth. So between these 2 points, if we just look at between these 2 points, the input end and P is maintained at 0 voltage because it is virtual earth. V input minus 0 is divided by the resistance input. I equals to V by R. Now this is I through RF. This is here the voltage output. and this is P which is maintained at 0. This is the junction from P to voltage output. So look at this, from current is flowing from P to voltage output. So right here P is 0, voltage output is P output, and it flows through the resistance RF. Did you get this expression? This one, the one that I wrote here. Could you get this one? Sure. This end is the input voltage. This end is P. The current is flowing through this resistance Ri. Just think about a simple circuit. This is resistance. These are the 2 points, point A, point B. The point at point A, the potential is VA. At point B, the potential is VB. And this is the resistance R. This is the current that flows through this resistance. So can't we say this I equals to the potential difference between these 2 points A and B, which is VA minus VB, divided by R? Can we or not? The same here. This is the end where the input voltage is supplied. This is the point where the voltage is 0 because P is at virtual R. And this is the resistance through which I flows. So this is the junction you have to think about. The current through input resistance is same as current through feedback resistance. So input resistance is in between these two potential. One potential is the input voltage, another potential is potential at point P, which is 0. So it is input voltage minus 0 divided by the resistance in between these two potential, which is input resistance, which is same as the current through feedback resistance, because all the current will be flowing through the feedback resistance. No current will be entering into the Opamp because Opamp has infinite input impedance in its internal circuitry.